actually two parts actually. First one is about the neurons and also the neurophysiology. Okay, so we will cover this today. The other part which has to do with the muscle. Okay, I will do it in a async lecture. Yeah? Okay. So first of all, okay, we need to know that where does the bioelectrical potential okay comes from. Okay. Um, when you know the physics, okay, when you know the physics, how does the nature works, okay, um, people observe that there's actually a bioelectrical okay in organisms, okay, like for us, okay, um, and most of the mammals, okay, even like okay, you can see even even invertebrates, okay, even like squid and so on. You can okay, you can see that there's a bioelectrical potential, okay, that is due to the electrochemical reactions of a certain type of or certain class of cells. Okay, so these cells can be excited. Can be excited. That's why it is called excitable cells. Okay, that's why you can call them excitable cell because you can excite them. Okay, you can make them excited. Okay, maybe by using electricity and so on, you can see that they can be excited. Okay. So what are those three? Okay, those three cells are the nervous tissue, okay, nervous cells, okay, muscular tissue, muscular cells, glandular tissue, glandular, okay, like the glandular, okay, this glandular with like your thyroid, okay, there's a type of a tissue, okay. So we go to this part later on. It's about resting potential. So all these tissues, okay, they can exhibit the resting potential. Okay. So when it is stimulated, okay, it is stimulated, you apply some voltage, okay, you can see that, okay, that there will be an action potential. There will be an action potential that can be generated. So this action potential is the origin of all our okay biopotential. Okay, now this is our neuron lah. Okay, this is our neuron. Sebentar tu. Okay, everybody hears me? Semua dengar?
Dengar.
Yes,
Dengar,
Doctor.
Doktor.
Okay, thank you. Okay, just want to have your response. Takut hilang Okay, so coming back lah kan. Okay. Okay. So this is our neuron. Yeah. You know our dendrites. Okay. You have the soma. Okay. You have the nucleus, axon, hillock. Okay. The myelin sheath, axon terminal. Okay. So I hope you can learn this by heart. Okay. And you can say that this is the main component of the human nervous system. So this is our neuron. So if you can look at the notes, okay, if you have downloaded it, okay, there's a explanation, okay, for page 5, 6, and 7. Okay, so it says here, okay, every neuron has a single axon. Okay, single axon. You can have a single axon here. Okay, okay. So the diameter. Okay, diameter for us humans, human brain. Okay, it is like a micrometer. So 1 micrometer is very small. You just imagine kan. Your 1 millimeter is divided into 1,000. You divide it by 1,000. So that is your 1 micrometer. And then it can be up to okay a milliliter lah. A millimeter, sorry, millimeter. In a giant fiber of the squid. Okay, I've read about squid. So Squid is okay. This is a funny animal actually. Okay, why is I call it a funny animal? Okay, I watch. It's not squid lah. It's actually cuttlefish. But it's the same category. Ni dah masuk macam apa? Zoology sikit lah. It's a cephalopod. Okay, it's a type of mollusk. It's a type of mollusk. Okay, we have a gastropod. We have a bivalve. Okay, those who are going to plan, if you want, you are interested to do FYP with me. Okay, I'm working on the shells. If some of you heard about me. Okay, I'm working on the shells. Okay, I'm producing hydroxy appetite from shells. Okay, so the shells can come from gastropod and bivalves. Okay, gastropod is like like siput. All those siput apa nama ni, siput sedut. Siput nak sebut tak sedap lah kan. Apa nama ni, siput babi kan. Okay, those are gastropod kan. It has a house. I know those who like to watch SpongeBob, Gary. That's gastropod. Okay, the one like Lala, kerang and so on. There's a bivalve. Okay, but we have another type of mollusk, which is cephalopod, which is the squid, cuttlefish. Okay, so this cuttlefish, okay, it's a very sophisticated invertebrates. Invertebrates, no tulang belakang, no spine. Okay, no tulang belakang. Okay, no spine bone. Okay, it can mesh. Okay, it is good in camouflage. Okay, and I'm not sure. Okay, but looking at the information that in the notes. Okay, it should, okay, it has a millimeter, the size of fiber of the squid. Okay, it's a millimeter. I'm not sure about the cuttlefish. Okay, but okay, it can imitate the color of the seabed. Okay, coral. It can imitate the sea cucumber. Okay, so it is very advanced. Okay, and I think one of the this is contributed by the advanced neuron system. Neuron system of a squid. Okay, so coming back to our notes. Okay, axons are specialized for the conduction of particular type of electrical impulse, okay, which is the action potential that we are talking about. Okay, it's going outward, okay, away from the cell body, okay, from the cell that they shown here. Okay, we have the nucleus, okay, we have the soma, and then we have the dendrit. So it's moving away through the myelin sheath, okay, then towards the axon terminals. Okay, so an action potential is a series of sudden changes in the voltage or the electrical potential across the plasma membrane. So after this, we will go to the plasma membrane a lot. Okay, we will see the control of ions coming in and out of the plasma membranes. Okay. When the neuron is in the resting state or non-stimulated, the electrical potential across the external membrane is approximately negative 60 millivolts. Okay, so the inside negative, okay, is relative to the outside. So that is our what we call reference. That's our reference. The magnitude of this resting potential is similar to that of the memory potential in most non-neuronal cells. Okay, at the peak of action potential, the memory potential can be as much as 50 millivolts. Okay, and okay, so the difference, okay, the net change is 110 millivolts. Okay, this depolarization of the membrane is followed by a rapid repolarization, returning the membrane potential to the resting value. These characteristics, okay, distinguish an action potential from other types of changes in electrical potential across the plasma membrane and allow an action potential to move along an axon without diminution. So you can see that, okay, every action that we do, okay, even like now I'm talking, okay, you are now maybe looking at the laptop, okay, or at least you are hearing, okay, this lecture. All our axon, okay, all our nervous systems are communicating, okay, communicating. These are electrical charges. This is what called all these action potentials are happening inside our body. Okay, so but okay, I also okay just to like to tell you okay about some okay when I go to the and I deliver a course. It's on the anatomy and physiology, but for those who have already worked, okay, last time 2 years back before before COVID-19, I went to Penang. Okay, I gave it to Agenta. Okay, they asked me to teach anatomy and physiology. Okay, usually the strategy I know you must think that okay, there's a lot of things you have to remember. There's a lot of things you have to memorize. Okay, but at least okay, you need to know the body first. Okay, you know the nucleus, okay, the body, and then you don't know the dendrite. Okay, then Ascent Hillock, okay. After this, we will go to okay. There will be more explanation on how this action potential works. I mean the conduction of the action potentials. Okay, then this the what I call the myelin sheath. Okay. So this is okay. You can see that this will help you. Okay, this is about okay the integration part, and then the spike initiation, the conduction of the impulse, and then the transmission. This transmission. Okay, and then finally is axon terminal. So I know you may have some difficulty to remember it at the first time. Okay, but please chop it. Okay, chop. I call it chop it into. Um, Information that you can memorize easily. Okay, first remember the body. Okay, and then try to remember the myelin sheath. Okay, and then the last one is axon terminus. Or maybe you just remember about the body first, and then myelin sheath, and then the axon terminus. Okay, so I know this is like even like for SPM, I'm not sure your batch. I just posted in my Instagram. Okay, so showing the in my UPSR paper in 1990. Okay, you can see. Okay, it's still with me. Then the paper is 31 years old already. Okay, 31 years old. Okay, maybe as old as your pakcik or your makcik. Okay, so so I'm not sure about your syllabus lah. When you first okay, but from my batch, okay, those who study, I'm from biological background. Okay, we study this during our asasi matric asasi STPM. Okay, we haven't learned in during our SPM. SPM we haven't gone to this yet. Okay, okay, let's move to another page. Okay, so these are the type of let me move this. Okay. Okay, this is the type of neurons that we have. Okay, structure of a typical mammalian neuron. So every mammal, okay, should have this. So means cats, ticos, okay, cats, rats, mouse, okay, humans, primates, okay, should have this type of neurons. Okay, so first of all, okay, if you want to chunk this, first of all, if you want to memorize this, I know I'm not expecting you to know everything, okay, but to make it simple, okay, first of all, the name lah. The multiple, okay, this is multipolar. So it should have two pole, okay, multipolar interneurons, okay. That I told you, dendrite, if you know dendrite, okay. Then you have the cell body, okay. And this is the axon, and then the axon terminus, okay. Okay, and then you have another two, okay. Or you can start with one is motor neuron to control action, another one is sensory, for your sense, okay. Your maybe your okay, maybe you feel, okay. feed, okay, to feel things, okay. Uh, so okay, maybe like your if okay, like maybe your smell, for your smell, okay. So it's easy for you, okay. Yang pening kepala dulu, okay. One is for motor, one is for sensory. One is for motor, one is for sensory. Okay. So each of them, okay, should have, okay, for motor, okay, you need something to be controlled. Betul tak kan? Okay. Is it correct? Okay. You need something to be controlled. So what is the easiest to be controlled in your maybe if you want to memorize something? Okay. Use muscle lah, muscle, because we can move, huh? Betul tak? Okay. Then we have this, okay. You have this, okay, all the same axon for the multiple interneurons also have the axon hillock, okay. So for the motor neuron also axon hillock. So don't worry too much about apa nama ni, about making wrong, but you have to, okay, you have to revise back lah, okay. So you, first of all, anything you have to see the difference. That's right. One of the way to learn is that you see the difference. Okay. For instance, for this for the A, okay, I don't want to, bulan puasa my mouth is also kering now. Okay, it's dry. Okay, so I want to talk more, but if I can cut it short, I will cut it short lah. Okay. So you can see for this multipolar interneurons, it doesn't have the myelin sheath. Okay, it doesn't have myelin sheath. Okay, for motor and sensory neuron, you have it. So you have to see what is the difference. Okay, what are the differences between all these? Okay, so for motor neuron, you can see, okay, it has a myelin sheath. Okay, so not of Renvier. We won't go so detailed like what you learn during the STPM or maybe your matrix SLC and so on. Okay, but okay, because the info, okay, because now we are trying to see what is the how this the action potential generated. Okay, okay, so these are the one of the part of system that contribute to it. Okay, so you can see that okay, this is cell body, then you have the axon, okay, and then this is a node of Renvier, and then both, okay, you have myelin sheath, okay, and then you have this neural muscle synapse, the synapse. So this is the terminal, the terminal of it, and then you have the muscle. Okay, I think this is the perhaps, okay, maybe this one is the easiest, okay, because it doesn't have the myelin sheath. Okay, you have the cell body, and then you have the dendrite, okay, and then you have the axon and the terminals. Okay, the bit complicated is a sensory neuron. Okay, you have the receptor cell. Okay, why it has three? Okay, because we just want to show, okay, it has some branches and so on. Then you have all these myelin sheath, okay, and then the axon, okay, the cell body, okay, the cell body, if like for the A and B, okay, motor neuron and multipolar interneurons, okay, it is on the top, but for the sensory, it can be, it's not on the top lah, okay, so maybe in the middle or so on, okay, and then you have the axon terminals. Okay, so this arrow, okay, so this arrow indicates the direction of a conduction of action potential. Okay, so for multiple interneurons, each has a profusely branched dendrites. Okay, there's a profusely branched dendrites which receive signals at synapses. Okay, with several hundreds other neurons and single long axon that branches laterally and its terminal. So okay, it will connect to hundreds of other neurons. So how about the motor neuron? A motor neuron that it innerves, okay, means that it connects to the muscle cells. Okay, so it has a single long axon extending from the cell body to the effector cell. So this is the effector cell. Okay, in mammalian motor neurons, an insulating sheath of myelin usually covers all part of the axon, except at the node of Renvier, nodes of Renvier and the axon terminals. So you have all the sheet from myelin here. Okay. Okay. For sensory neuron, the axon, okay, branches just after it leaves the cell body. Okay. Which is located in the dorsal root ganglion near the spinal cord. The central branch carries the impulse from the cell body to the spinal cord of brain. Both branches are structurally and functionally axons, except their terminal portions, even though the peripheral branch conducts impulses toward rather than away from the cell body. So these are the difference lah kan, okay. So like I told you, okay, you study, okay, you first of all study the anatomy of the neuron first, okay. How does it look? Okay, how does it look? Okay, and then how does it work? Okay, so how does it work? Okay, it is in the bottom of the notes. Okay, so you can have a look there. Okay, so let's see the neurophysiology of it. Okay, now it's the theory. Okay, we have 96 attendance. Okay, hope more people comes. Okay, I know. Okay, I hope that those who are still not here, okay, they will come. Okay, they will come as soon as possible. Okay, so neurons, okay, highly irritable. Okay, when adequately stimulated, and the electrical impulse is conducted along the length of this axon. Okay, so it sounds that it's easy, but you know that in our body, okay, there's maybe like billions of it. Okay. Okay, so this is very complex. Okay, but from there, okay, we have all our movement, we have our sensory, and so on. Okay, some of it maybe we what we call deliberately. Okay, like when you're talking, okay, we want to hold something, we want to touch something, and some are not deliberate. Okay, we cannot control it. Even like when you want to go toilet, you cannot control it. Okay, when to go to you want to go toilet. Sometimes you feel stomach ache and so on. So that's something. You see that even we don't some then this is what God's creation. We shouldn't be too what I call macam nak cakap membangga diri in Malay we call membangga diri ujuk and riak because of we can control even with some of the thing in our body the movement of our stomach and so on the process of our okay to digest food is not in our control. Okay, when we want to say something, it's our control. We want to look at something, it's our control. But then, when we want to, like the process of digestion, even like process of breathing and so on, it's not even our control. So these all are done. Okay, with okay, all this control, all this done by this electrical impulse. Okay, the nerve impulse, okay, known as action potential, is always the same regardless of the source or type of stimulus. Okay, underlies virtually all functional activities of the nervous system. So that's why like when you feel pain, it's actually a blessing, okay, because it tells something wrong with your body. And you have pain, okay, when you feel not comfortable, okay, this is how your body tells you, okay, there's something wrong with your body. I know we want to be like Superman, we don't want to be painful and so on, okay, but if you don't feel pain, okay, that's why when you are at my age, okay, you and I think you also watch TV, especially during the break time. There's a advertisement about diabetes. Okay, people with diabetes, they may lose the ability, okay, to feel, okay, because of diabetes, because the sugar is damaging the nerves, okay. So I know, okay, becoming diabetic doesn't mean you become Superman because you cannot feel pain, okay. But later on, that's why, okay, this will create problem. Okay, this will create problem because of, okay, that's why if you heard about, okay, those with diabetes, okay, may get their legs or parts of the body amputated, because when the nerves died, okay, it's no longer working, uh, it doesn't feel any pain, okay. If something wrong with the leg, okay, with the part, with the tissue, the leg tissue, some part of it, okay, exposed to, maybe it is has injuries, cut or something, okay, and the body can no longer what I call it, kira cure lah kan, membaik pulih lah. It means that that part is cured and then the part will die. Yeah, and that's why you have the gangrene, where the tissue died. So that's why, okay, um, when you learn this, okay, and then you relate it with yeah, because you are biomedical engineering students, okay. If you please have like maybe like if you read, maybe yeah, like if you heard stories and so on, so try to relate it with whatever you learn. Try to relate it with whatever you learn. Okay, so because try, like I told you in the lecture previously, please don't separate whatever you learn in the class, okay, with the outside world. Sometimes you feel that, oh, it's a boring things to come to classes, okay, because of okay, class is just for exam, okay. I know, I understand, okay. I was also at that stage last time, but you have to remember one thing, okay. I try to make it as near to you as possible. I know, um, maybe okay, maybe, but those who have relatives, okay, relatives that has diabetes, you may appreciate what I'm telling you now, because okay, oh, this is why, the reason why, okay, uh, you need there are some supplement, which can help to improve the nervous system, okay. But this is due to what we learn now, what we learn now. Okay, let's see at the notes, okay. So it tells you, okay, the notes is about the speeds, so this is one of the uh, how advanced is our body, okay, like I told you last time, okay, like I told you in previous lectures, okay. At first people thought that something artificial is going to be better. Even now, okay, sometimes, oh, you see Iron Man, you're impressed with Iron Man, but actually we are the Iron Man. Okay, you can see, we are impressed, oh, with those technology. I know technology helps people, okay, but then actually our body is a so-called in bracket, is a Iron Man by ourselves. We can see that, okay, this action potentials, okay, move rapidly at speeds up to 100 meters per second. Okay, so it is faster than the Usain Bolt and so on, okay. In humans axons, okay, axons may be more than a meter long, yet it takes only a few milliseconds. Just imagine, few milliseconds for an action potential to move along their line. So it is very fast, okay, because it is a electrical in nature. That's why it's fast. Okay, so coming back, okay, if you look at the notes, please refer back to the okay, page number 5, page number 5, okay. An action potential originates at the axon hillock, okay, axon hillock, okay. You can see here the axon hillock. Is that like at the neck lah? You can see at the neck here. Okay, the junction of the axon. Okay, this is the axon and the cell body, and it's actively conducted down the axon into the axon terminal. So you imagine how fast is it? This is a short one, so no problem lah. No problem. Okay, but just imagine like a meter long, so it just takes a few milliseconds, few milliseconds. Okay, okay. Into the axon terminals, okay, small bunches of the axon that form the synapses. Okay, so the connection we call it a synapse. Okay, a single axon in the central nervous system can synapse with many neurons and induce responses in all of them simultaneously. So if you look now, okay, maybe we feel that Ini tak ada apa-apa lah kan. It is not saying nothing lah. It is still advanced lah kan. Correct kan? It is still advanced. But last time maybe during, okay, when I first learn anatomy physiology, this is wow kan. Okay, now we know the internet. Okay, internet. How fast is our internet? So you just imagine lah how much like 300 megabyte per second been downloaded. So you just imagine lah kan. But that's why how we advance, okay, by looking at the nature actually. Okay, that's why if you are planning, okay, to be a researcher, okay, you plan to be a researcher, you want to improve, okay, systems, okay, sometimes you have to go back to nature and how does it work, okay, how does the nature works, okay. So by copying, by understanding and by copying, okay, we can we may improve the system. Okay, I know some of the what we call the solution. Okay, some of the solution maybe 100% mechanical. Okay, 100% mechanical electronics. Okay, but then okay, definitely I can assure you. Okay, especially if you are working in biomedical engineering. The solution in nature sometimes is very amazing. It's amazing. So if you look at how this the neuron system works, how does this the neuron system works, it is very amazing. It just remind you of how you are using your IT, how you are using the IT, how you're using the technology that we have now for information. So and now I think you can appreciate it more easily when compared to my generation. Okay, let's go to page number 8. Okay. Now just now we talk about the apa nama ni with the neuron. Okay, okay. Just 1% comes in. Now we have okay 2. Okay, 98. Now we have the 98. Supposed to be like 110. Okay, 110. Okay, hope your friends comes in. I know you are relative puasa, but still okay. Class have to move on. Okay. So, okay, now we go to plasma membranes. Okay, last time I think when you first learn your cells, okay, this is one of the most boring part of all lah. Just to safeguard the cell. Okay, you are more impressed to see the mitochondria, the nucleus, and then another one is cytoplasma. What apa lah dia buat situ Okay, but now okay, we will see every each of these creations, all of these it has function. Okay, it has function. Okay, so plasma membranes are peppered. Peppered means that okay, you just imagine like pepper lah kan in your mushroom soup lah. Peppered that okay, if the membrane cell and then you have a dot there lah. Okay, so okay, it has a variety of ion channels. Okay, so dia banyak, it has a lot of lubang lah. It has holes. Okay, which are made of membrane protein. Okay, it is not just hole. Okay, you look it like a hole. Okay, first of all, tak ada apa, and then after that when you see, okay, this is something. Okay, and then okay, so there's two types of channels. Okay, two types of channels. Okay, there is a passive channels. So passive means it's open, always open. Always open lah. Okay, like our sempadan, Kedah Perlis, okay, always open. Unless we have COVID now, okay lah, you coming in then dikacau lah. Okay, last time it's always open. Okay, no, you can pass it, you can go through, you can go to Changlun, you can coming back from Changlun, no problem, just like that lah. Okay, so this is passive channel. Okay, always open all the time. And then you have a gated channel. Gated channel. So okay, have a protein molecules, okay, that open or close in response to various signals. Okay, don't be afraid about this wording, signals, but one thing, okay, it is about the movement of natrium ions and also potassium ions. Potassium is gallium. Okay, I know some of you, because you have last time learn biochemistry, lupa. Okay, I know potassium, this is like a British and also the American, and the proper one is kalium lah, K, because we have K, kalium. So and then the support, okay, and then but it's popularly called in the US and so on as potassium. Okay. So if you don't want to confuse, okay, whenever you see the potassium, okay, change it to kalium fast. Okay. You change it to kalium now. Okay. But if you are okay, tak apa lah. Potassium, kalium doesn't make any changes. Okay. You are not confused. Tak apa, maintain. You just maintain the potassium. Okay. I hope international students comfortable Okay, because sometimes I mix with tak ada apa means nothing tak ada apa and so on. I hope you're okay Okay, although all the words I use in English but sometimes I do use Malay term okay. I hope you are not. I hope it doesn't disturb your concentration okay, or make your learning more difficult okay. Just a simple words simple these people say they call it they say this Malaysian English okay. Okay, but if you feel lost suddenly, please tell me. Okay, okay, thank you Anwar. Okay, appreciate your response. Okay, sikit-sikit, just a little bit, it's okay okay. Because I think a challenge for international students okay, especially if you have to appreciate the international students because most of them okay, they please correct me if I'm wrong okay, they most of them they don't learn English during your maybe in your primary, your secondary, isn't it? And some of you just learn it during, maybe you will learn it, but maybe it's too simple, okay. But in the end of the study now, when they are third year and fourth year, they can speak, they can communicate in English very well. Excellent. For me, it's a good change. I hope I hope this is something that most of local students can appreciate their struggle. Okay, they can text us in English. Okay, very well. So this is the challenge. Okay, and then please facilitate them. Okay, please facilitate them because they come from far. Okay, that's why sometimes okay, I do campaign this nine page. We have like 31, but we can go fast after this. Okay. What I want to say just now. Okay. Because they struggle at the beginning. Okay, they struggle at the beginning, and then in the final year they manage. Okay, they manage. That's why I encourage you guys. Okay, if you have a chance. Okay, I'm not sure whether I told you about this or not. Okay, if after your graduation, if there is an opportunity maybe to go abroad, like not jalan-jalan lah, not for tour. Okay, because if you go as a tourist, everything will be very beautiful. Okay, maybe you have maybe you can do attachment because last time in the UK they have this scheme they call it for youngsters okay, below 28 you can they have a not grant they call it as a scheme they support you to stay there, have some experience. I'm not sure about Japanese or Japan, sorry, Japan or Australia or New Zealand, okay, but it's a good experience because for me it is good if you experience different culture, okay, different culture. How I know, okay, in terms of doing like postgraduates, okay, to tell you the truth, the technology that we have in Malaysia is as good as the one that we have like in the UK, okay. I've been there, okay, in the UK, in Australia, okay, in Japan. Maybe the what you call the most advanced is still in the still there lah in the US and so on, okay. But we are not lagging. That we're not far lagging behind them, okay. you are at par. But if you have the chance, is to see the people. Okay, some of you may feel that all the apa, orang putih is the white people are very smart. They're not. Okay, even Japanese. Okay, but you can see that the Japanese are very disciplined. Okay, they are disciplined, and then the what call the white people. Okay, they are. I'm not saying that they are, but they are more truthful. They are more truthful. Means that if they are okay, I just tell you a bit about the culture lah. Okay, if they given a task, okay, like for instance, if they work in office, okay, they will work from 8 to 5. Okay, they are working, they are doing the work. Okay, they like us sometimes maybe okay we tend to make something else lah, kan? Okay, maybe check WhatsApp and so on. Okay, maybe post something in social media or something like that. But they are truthful. Okay, they are truthful to their work and they do their work. If it's 9 to 5, 9 to 5, they do their work. Okay, they don't do anything else. Okay, but after that, don't disturb them. But you can see in Malaysia is okay, and then if let's say, okay, just give 1 more minute, okay, sembang-sembang sikit, okay, there's a chat, okay, not to make you boring, okay. But one thing about them, if let's say lah, okay, if you go to office, okay, if the crony, if the what you call if the clerk, if the person in the office, they just in charge in terms of your registration, and you ask for what, if you ask for something else, maybe about what, registration. Okay, maybe you ask for your convocation. He or she is nothing to do with the convocation. She or he will say, this is none of my business. But for us Malaysian, okay, we help you because this is small matter, so we help you. So this is different culture between what Australia or maybe UK, okay, and also from Malaysia. And just I want to add up, okay, there's a different culture also. I'm not sure, okay, all Arab, okay, all Arabs are the same. But I know one of my students, okay, last time I don't want to mention the name, okay, he said to me, if you want to say something, jangan cakap belakang. Don't say behind my back. Say in front of me. Okay. If you are not certified anything, just don't say behind the back. Because the Malaysian culture sometimes we don't want to hear the truth. We better tak apalah dia cakap. It's okay if you cakap belakang, okay. But you telling the truth in front of me, you feel that okay. After that, it's more painful. Okay. But so these are the things that you have to learn. This different culture. Maybe for even sometimes you don't actually understand. Okay, the Chinese culture, Indian culture. What are the things that okay can what I call induce in happiness, okay, bagi sakit hati, okay. Sometimes these are the things. Sometimes we have a lot of culture here, so maybe okay, maybe from I know we don't have much time. We just have like 1 year, slightly more than 1 year or something, okay. But please, okay, know each other, okay, and hope your friendship can last until forever. Okay, coming back to our class, sorry. Okay, active channels, we have two types, transmitter gated, okay, and voltage gated. This will be this will be elaborated in the next few slides after this. Okay, so each type of channel is selective to types of ions to allows to pass. Okay, so so this is the special things about this. This channel is selective to type of ions. Okay, it allows to pass. So we have the sodium and potassium. So let's say you are not comfortable with potassium. Okay, you can put K here. So meaning kalium. Just pangkah lah. I mean you cross it and put kalium if you are not comfortable lah. But if comfortable, just continue with potassium. Okay, so this is how does it look. Okay, so this is how does it look. Okay. So this membrane ion channels. Okay. So you have the natrium here, the receptor. So So now this is made from lipid. This is the ion channel. So this is your uh, this is your cell membrane. This is your cell membrane. So it's chemically gated. Okay. So now the ion channel is closed, and then you have the here. This is neurotransmitter chemical attached to a receptor. Okay. So when there's order, okay, there's a what we call a signal. Okay. Okay, like for instance, okay, to pass the natrium. So okay, the natrium oxide, okay, move in, moves in. Okay. Oh no no, yeah, moves in. Okay, this is A. Okay, and this is B. So for voltage gated ion channel, now is closed. Okay. So now is a voltage gated ions. Okay, channels are open. So the natrium will move in. Okay. Okay. When the gated ion channels open, okay, the ions diffuse quickly across the membrane of following their electrochemical gradient, creating electrical currents and voltage changes across the membrane. So, okay, so gradient, okay, in Malay they call it kecerunan lah, okay. There's a slope, okay. Slopes means that one is more, one is less, okay. Yeah, so it is based on maybe it's electrical. We will see. Okay, what's the meaning of electrochemical gradient of this? Okay, but to give you some idea, okay, it means that there's a difference. Okay, of the electrical situation there, and also the chemical, which is more, which is less. Okay, okay. So this is governed by this is our friend, good friend, Mr. Ohm. Voltage, okay, this is Ohm's law, okay. Voltage equals to current, okay, VIR, okay. Current times resistance, okay. In the body, electric currents reflect the flow of ions, okay, rather than free electrons across cellular membrane. So, okay, so you need to, okay, understand that these ions are more influential rather than the free electrons. Okay, so don't worry about all this question. It is answered. It is answered. Apa nama ni? In the next slides. Okay. 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 So what is the meaning of electrochemical gradient? Okay, so you have to consider two of these. Electrical gradient, what does it mean? Ion moves to the area of opposite electrical charge. Okay, easy. Okay, one is positive, one is negative. Okay, so if you have a positive ion, so it will move to the negative side. Okay, if the ion is I forgot already. Ion is negative, go to positive. Ion positive, so it goes to negative. Okay. So you draw a bit lah, okay. This part, okay, this is this knowledge, okay, is very fundamental and very powerful, okay, until the end of your final year, okay. You will see this anode, this cathode, everything. So this idea is the same. This idea is the same until you graduated, until you graduate. This idea will remain the same. So don't get confused, okay, and please have it. I know some of you are this is cincai lah, senang, very easy. Don't need, you just like you eat, you just take something and put it in your mouth and then you telan, okay, you just yeah. So as easy as that, okay. Some of you, but some of you maybe need to struggle a bit more, okay. So if it is good for you if you can draw a bit lah again. How? Okay, this okay, you have two sides, okay. One is positive, one is negative, and then the ions is. Okay, the ions, if you put the positive, so it will move to the negative side. And then this chemical gradient, okay, it's about the concentration lah. Okay, it's about the concentration. Okay, the ions diffuse specifically, okay, from an area of high concentration to a lower concentration. So this idea, okay, this simple idea of physics, explains everything. Not explains everything. It explains many phenomena. Okay, about pressure. Okay, high pressure to lower pressure. Okay, that's why we have all this typhoon. typhoon, and so on. Okay, so if you have and the idea of like even like if during kebakaran, during fire, okay, during fire, so why you are advised, okay, to crawl, not to stand up and run, okay, because of, okay, the heat is, okay, it's going up there, the heat is going up, and then the lower the lower part are more colder, okay, because of this movement. I know it sounds that, okay, maybe it has some, yeah, but this gradient, this, I just want to give you the idea of gradient. Means that the slope, and the normal one is that, okay, it's about the concentration. Excuse me. Okay, so we go to 13. So now how do measure the resting potential? Okay, so you have the voltmeter. Potential is always voltage. Okay, so you have the macro electrode outside the cell. Okay, and then you have the macro electrode inside the cell, and this is your plasma membrane. Okay, so the plasma membrane, please relate it with here. Okay, this neuron. Okay, so you just take a part of it. Yeah. So these are the thing that the advancement of bio research. So we want to know what happens, inside our body, what happens inside the cell. So people have measuring this, and then this is the basic of many our like researchers to understand what happened in our body. Yeah? Okay. Okay. So the potential difference between 2 points is measured by using two microelectrodes connected to a voltmeter. Okay, this is what we see just now. Okay, and then the potential difference between the inside and the outside of the neuron membrane. Okay, measures about negative 70 millivolts. Okay, the cytoplasmic side of the neuron is negatively charged compared to the outside. So you can see. The inside, the cytoplasmic side meaning is the inside of the cell. Okay, let's say if you don't want to get it confused, okay, use imagine, just replace the word neuron with cell. Okay, so when it is outside, it will be negatively charged. Okay, it is outside. Okay, inside. So it's negative. Okay, so this is like the resting potential. No excitement yet. It is in the state of rest. It is resting. No stimulation yet. Okay. So it should be the standard. Okay. negative 70 millivolts. Okay. We just use this number. Okay. Maybe there will be difference. Okay. Because this is bio. Okay. So but we put it as a negative 70 millivolts. Okay. Okay. Let's go to page 15. Okay. Okay. So this potential difference. Okay. Uh, is negative. Okay, that negative 70 millivolts is the resting membrane potential. Okay, okay. So during the resting state, the membrane is known to be polarized. Okay, the range of resting potential, that's what I told you. It depends on the apa nama ni, on the types of neurons, cells. Okay, neuron cell. But we take it as a standard negative 70 millivolts. So let's say, okay, if you want to answer a question, okay, if we don't give you, okay, what is the resting potential, assume it is negative 70 millivolts. Just assume it's negative 70 millivolts. Unless if we tells you, okay, it should be like 85, 50 or something. Okay. Maybe, okay, yeah. So you have to be aware. Okay, you have to be aware about the given the resting potential. Okay, if not, just take it as negative 70 millivolts because it is in the middle. Okay, okay. So these are the questions. Okay, just read the question. Don't worry because we have the explanation in the next slide. Okay, okay. So this is what, okay. Sodium and potassium plays the most important role in generation of membrane potential. So, and you know, just okay, sembang-sembang balik. Okay. Um, the what we call even in terms of medicine, in terms of medicine, okay, I don't know whether I tell you this or not, maybe to your senior last year, okay. Um, like for instance, the medicine for apa nama ni okay, for blood pressure, okay, for blood pressure, okay. This have been around like 10 years back, 10 years ago, okay. But at the time, it's a really a blessing lah, yeah? Because okay, before that, okay, before that, uh, how people want to reduce the blood pressure? One of the through medicine lah, through taking medicine. Um, what they do is that they bring down the pressure. Okay, they bring down the pressure. Okay, but unfortunately, everything goes down. Those what I call anything function in the body that requires pressure cannot cannot be functioning. Okay, then they go to next level. Okay, they know that okay how to make pressure better. Okay, how to lower down the pressure is by dilating the blood vessel. Dilating the blood vessel. Okay, because the blood vessel will be more rigid, and then they will be more constrict. Okay, in the person with the blood pressure. Okay, so this medicine is better. This medicine is better compared to the old generation. Okay, yeah. You can browse the internet. Atenolol, atenolol, ATENOLO, and yeah, atenolol. You can browse it in there. Yeah, just for your knowledge. Okay. So, however, the second generation is also not that good at that time because, like for instance, a person that should have 120 millimeter mercury blood pressure, what happened there? Okay, they got it like okay lah. It's not that it's high, but it's not as high without medicine. Maybe if without medicine, it can shoot up until 200 millimeter mercury. Okay, God forbid. Okay, Alhamdulillah. Okay. But with that particular with that medicine, okay, amlodipine, besatylate, okay, it becomes like 150, 140. Still high, but not as okay, but better lah kan than 180 millimeter mercury. This is what I want to tell you. Okay, then around like 12, 13 years back, okay, there is a type of medicine. It plays around the membrane cell membrane. Okay, it controls about the natrium diffusion because you know blood pressure. Okay, you cannot eat a lot of garam kan, a lot of salts and so on. So okay, it plays around the cell membrane. So this generation is much better. Okay, you can get the blood pressure okay down to 120, 130 lah, 120 to 130. Okay, plus the amlodipine that I told you just now. So that's why okay, that's why sometimes I'm not sure whether sometimes you ever cross this in your mind. Okay, why we are so susah-susah taking all the trouble to learn this anatomy, physiology, this cell is not going to be. Some of you feel that lama, especially after your LI, after your latihan industri, industrial training. Some of you when you go to company, why I have to learn thermofluid? Why I have to learn anatomy, physiology? Why I have to learn all these calculus? For this three integration, I'm not going to use it. Okay, the reason why is that okay, if you are going to other field, especially if you are going to research, okay, if you are going to okay, do this type of projects, okay, something to do with high high innovation, okay, highly related, high impact innovation and so on, okay, this type of knowledge is very useful. Uh, so it is not just to know the act, it is not just knowing some PPE, some PPE, some law, some, okay, maybe you just know the safety, okay, this type of medical device is class, which class, okay. I know this is useful, okay, especially for normal, typical working environment in Malaysia, okay. But let's say if you are going, okay, to go for technology, if some of you want to continue your study abroad, if, even in Malaysia, okay, this type of knowledge is very useful. So don't belittle all this knowledge, because this knowledge is going to help you somewhere and somehow. Okay. So we go to page 17. Okay. So this answers the question from the previous slides. Okay. Okay. Sel cytosol. Okay. Low concentration of sodium. Okay. Na plus. Okay. And high concentration of potassium. Okay, so this is inside the cell. Okay, please jot down lah. Please jot down here. This is inside the cell. Okay, I think semua okay ya, semua okay. Okay. Now we have 100. Oh, okay. Okay, so okay, so now you have to draw a bit lah. You draw a cell here. Okay, with one nucleus. Okay, just jot down here extracellular, okay, fluid. Inside here is the cytosol. Okay, so it has a low concentration of sodium compared outside. Okay, but high concentration of kalium. Okay, then this is how, okay, maybe to make you more understand about this issue lah. Okay, about the amount of concept of the sodium ion and also potassium or kalium ion here. Okay, the negatively charged proteins help to balance positive charges of intercellular cations. Okay, so this has two things. Okay, first of all, okay, this is more on the chemical. This is all on the chemical gradients. Okay, and this one is more on the electrical. This one is more electrical. So it has some, okay, the concentration of the ions. Okay, and this one is about the charges. Okay, is it negative or is it positive? Okay, so you need, okay, to make it the cells. Okay, the cells want to be neutral as possible. Okay, this is nature. This is nature. Okay, we want to be neutral. We always want to be neutral. Okay. 18. Okay, so this is what, okay, don't be confused. Okay, this is outside the cell. Outside the cell. Again, outside the cell. If I know sounds extracellular, sounds really so fancy, but you can put just, okay, outside the cell. Okay, like I told you, okay, because you are not in medicine. In medicine, they are really particular about each of the terms. Okay, so let's say if you cannot remember, if you say outside the cell, I give you full marks. Don't worry. Okay, I give you full marks. Okay, high concentration of sodium. Okay, this is outside. So outside there's a high concentration of sodium. There's a lot of sodium there, and then but the potassium or kalium is less. Okay, it's less. Okay, in the extracellular fluid, okay, the positive charges of sodium other cations are balanced chiefly by chloride ion. So, okay, inside the body, inside the cell, okay, the protein is going to make it neutral, but in the extracellular fluid, okay, so the chloride ions are going to balance it. Okay. So this is a new thing. I hope you can remember. Okay, about how we make sure the balance of the charges, okay, being done outside the cell and inside the cell. Okay, we can make a table. Okay, make a table. Okay, how you make it balance? Okay, you can make a table out of it. Okay, let's go to 19. Okay. Okay, so how does the ionic difference exist and maintain? Okay. Differential permeability of the plasma membrane to sodium and potassium ion. Okay. Ion. So permeability means how the ions can pass through. Okay. Layman term, orang biasa punya term. Okay. Layman terms. Okay. How can the plasma membrane, okay, let go or let in, okay, those ions, those ions, okay. And okay, and then we have a pump, okay, pump which can transport the natrium ions out of the cell and kalium ion into the cell. Okay, so first of all, the natural way of movement. Even like in the real world is we use also this concept. For instance, for water, okay, for water, okay. That's why sometimes, okay, I'm not sure any of you are having the problem. Okay, if you have a water problem, okay, back in your home, I'm not sure about in your asrama, okay, in your college, okay. Sometimes the water cannot goes to the tank, to the water tank up there, okay, because the pressure is low. Okay. If you are in a single story building, it's easy. It's easy. But let's say lah, you stay in tingkat 5 or on the fifth level, sixth level, seventh level. If you're in KL, sometimes up to 50. So how you are going to pump the water up? So this thing also happen to in our body. Okay, if let's say no, I know this is just just to make you understand easy. Okay, it doesn't have to be like that. Okay, but this is okay just to make you can understand this better. Okay, if in the normal situation, okay, you can have a okay, so this much of potassium ion in our cells. Okay, so maybe just a normal permeability is okay. But let's say you need extra, okay, extra potassium inside the cells. What are you going to do? So this is also the same that for the water supply, for the 30 story buildings. Okay, you need pump. Okay, so this pump will pump the kalium inside the cell, or maybe okay, and also okay, get rid of the natrium. Okay, so you have also the sodium operation pump. Like the water supply. Okay, that's why I told you. Whatever happen, okay, in the real world is actually okay the same idea you can also use to simplify, to make it easy for you to study. Kan? Okay. So I hope that okay. Please, that's why I told you when you, especially if you cannot, it is very hard for you to understand. Okay, certain topics. Okay, try to chop it off. Okay, try to chop it off first, and then later on try to relate it with because whatever we learn in the class is actually a real problem. It's a real issue. Okay, but we make it like even mathematics. I know it's like talking to aliens in the alien language. You have the delta, you have all this kameran, you have this integration, everything differentiation, and then and all that. Okay. So but okay, but it's actually trying to solve real issue outside. Okay. So never take out. Don't what we call don't separate two of these. Okay. Try to relate something close to you. Okay. If you have problems in understanding certain issues, okay, try to relate something that very close and very dear to you, so that you can understand it faster. Okay. Okay. At the rest, the membrane is impermeable to, okay, it tells you the state of the membrane. Here, it tells you the state of the membrane. Okay. At the rest, okay, the membrane is, okay, impermeable to large anionic cytoplasmic protein. So means that it should be, okay, it should be, in Malay called kebal lah kan. It should be impermeable. It cannot be penetrated. Okay. So to make you easy to remember, okay, no proteins lah. Okay, anionic. So anion okay. Anion means negative. Okay. Satu plasma. So it cannot be, okay, it cannot penetrated by this type of, especially this anionic okay, proteins. Okay. So sodium can go through it, okay, slightly permeable. Slightly permeable. So sodium may penetrate it, may go through it, okay. And then there's, okay, but potassium, okay, calcium, okay, it is easier for them to penetrate the membrane, okay. And chlorine ions can go, okay, ini dia tak ada masalah merentas negeri doesn't have any problem to go through ni tak payah pakai pas ke apa, tak payah pergi balai polis doesn't have go to balai polis, okay. For chlorine ions, no problem at all, okay. So this situation reflects the properties of passive ion channel. So this is for the passive ion channel. So there are 4 things you have to remember, okay. So okay, so the proteins, okay, the large and the ionic, cytoplasmic. But first try to imagine the protein first lah, kan. Okay, then you try slowly to remember all these four words, large and ionic, cytoplasmic, proteins. But first, just remember protein first, and then try to, okay, expand it to all these other 3 words. Impermeable, tak boleh tembus, cannot penetrate at all. Okay. Sodium, okay. So means that, okay, it is slightly permeable. Okay, so potassium, they like it so much, okay. And the chlorine ions, no limit. Means that freely, okay, don't need to go to balai polis for permission to raya. Macam tu lah, okay, it's like that. Then, okay, there's an Ernst equation, okay. So, okay, this is the Ernst, okay, Nernst, okay, equation, okay, RT divided by the F ln K naught Ki, okay. So, okay, you have, sometimes I haven't seen the, okay, universal gas constant, okay, the absolute temperature, okay, balance of, okay, the potassium, and then you have the Faraday constant, then intracellular concentration, extracellular concentration. Okay. So the next equation is an equation that can be used, okay, to determine the equilibrium reduction potential of a half cell in an electrochemical cell. Okay, so it can also be used to determine the total voltage or electromotive force, EMF, okay, for a full electrochemical cell. It is named after the German physical chemist who first formulated it, okay, Walter Nernst. So this is the one of the way to measure, to calculate the equilibrium potential for the potassium. Okay, so we have another question. This is Goldman okay, Goldman equation. If you consider other ionic species, okay, you have the RT, F, but you don't have the N, okay, the balance of K, because why? Because we don't consider other the only balance of K, okay, so no need for N, okay, so you have the universal gas constant, absolute temperature, and then you have to permeability coefficient of ionic species. So you have the one for kalium, you have one for natrium, and also for the chlorine. Okay. So this Goldman-Hodgkin, okay, the full name of it Goldman-Hodgkin-Kaas voltage equation, more commonly known as the Goldman equation, is used in cell membrane physiology to determine the equilibrium potential across the cell's membrane, taking into account all of the ions that are permeant to the membrane. So this is another equation. So last time tutorial we have it for this, okay. So please have a look back at the tutorial, okay. Please have a try. Okay. Stimulation, okay. Membrane potential used as a communication signal to receive, okay, integrate, and sending information. Okay. So membrane potential can be changed. So this is important. Okay. Um, Anything that changes the membrane permeability to any type of ion. Okay. And then anything that alters ion concentration on the two sides of the membrane. Okay. So you have to see the gist of it. Membrane potential. Okay. Okay. You use it as a communication signal to receive, integrate, and sending information. Okay, I'm sorry because today I didn't take a we didn't take a break. Okay, but we inshallah we shall finish it as early as possible. We have okay, okay 31 tak ada, tak apa. 30 we just have another eight slides, eight slides then we finish, Okay, I'm sorry to take you so much of time, but okay, but I hope yeah we can finish by 4:40 before 4:40, Okay. So this potential can be changed. Okay. Okay. What anything that changes the member permeability. Okay. So if you disturb, okay, the member permeability, maybe okay, you first maybe let's say you don't want to receive natrium, but you change it. You change it. Okay. You may receive more natrium. And okay. And then anything that alters ion concentration on the two side of membrane. So um, first of all, like okay, if natrium is higher on the other side, suddenly you can also alter it to be higher in inside. So these are the two things lah. Okay. Okay. Now we see the okay depolarization. Reduction in membrane potential. The inside of the membrane become less negative than the resting potential. Okay. Side positive. Okay. This is inside negative. The resting potential, the depolarization. Okay, includes events where the potential becomes positive. Okay, okay, and then you have the hyperpolarization. Okay, increase in membrane potential. Okay, the inside of the this is the maybe I deleted it somewhere during the while editing the lecture note. Maybe I deleted the T. The inside of the membrane becomes more negative than the resting potential. This is the hyperpolarization. So you look at the graph, okay, depolarization, potential becomes so it's nearly the same. Okay, okay. So this is the resting potential. Remember, negative 70 again. Okay. So, sorry. Okay. So at the resting potential, when it is a depolarization, okay, it's positive. Okay, hyperpolarization, it becomes negative. Inside of the membrane. Okay. So 26 threshold. Okay. The depolarization needs to reach certain threshold value to generate action potential. So it has, okay, before it can work, okay, it needs to reach certain threshold value to generate action potential. Okay, value approximately 50 millivolts to okay 20 millivolts of the resting potential. So action potential is all or none phenomenon. Okay, 1 and 0 lah. Okay, similar to a twig and the torch principle. I don't know what is that. Please, please Google it lah. Okay, similar to a twig and the torch principle. Okay, so please Google lah. I give you homework lah. Your homework is to find what is the twig and torch principle. Okay, tak susah kot. Okay, 7. Okay, so now we go to the action potential. Okay, the principal way of communication by neurons are by generating and propagating. Okay, action potential. Okay, so this is how the neurons work. Only achievable by cells with excitable membranes. So, okay, again, tengok balik. Okay, what are the those cells? Okay, remember the this nerves, okay, muscle, glandular, yeah. Okay, action potential is a brief reversal of the membrane potential with a total amplitude of 100 millivolts. You just imagine from the negative 70 millivolts to 30 millivolts. So, okay, the amplitude is high, yeah. Okay, from the negative 70 millivolts, okay, the nearest one, this is, so so it becomes high, okay, up here lah. Okay, let's see. Okay, okay, this action potential generation and transmission is identical in neurons and skeletal muscle cells. So it's nearly the same. Involve four main phases: resting, depolarizing, repolarizing, undershoot. Okay, so it tells you about how it is generated and how it is transmitted. Okay, so for neuron and skeletal muscle cells, it's nearly the same. Okay, and there's the four phases. Okay, let's see the explanation for those four phases. Okay, resting state, the voltage gated channels closed. Okay, uh, so this okay. It's good if you have a picture. Okay, if picture here, maybe you can draw it. Okay, besides your notes. Please print your notes. Okay, don't print for this lah. For this particular, don't print 20 page per 20 slide per page lah. This one, okay, maybe just one slide per page. That will be good lah. So you can have more space to draw. Okay. Depolarizing phase, increase in sodium permeability and reversal of membrane potential. Okay, so what happens in the repolarizing phase? Okay, so decrease in sodium, increase in potassium. So undershoot, okay, potassium permeability continues. So more kalium coming in. Okay, 30. So this tells you how does it happen lah kan. So okay, so sodium channel is closed, it's open, sodium ion center, then reset. So reversal of excitation, okay, negative 70, okay, the natrium channel is open, natrium ions, okay, natrium ion channels open, natrium ion begins to enter the cell, okay, then the cadmium channels open, cadmium ions begin to leave the cells, okay, natrium channel become refractory, no more natrium enter the cell, K continue to leave the cell, causing membrane potential to return to resting level. So the K, so it tells you lah. Okay. So extra K, gallium ion oxide diffuse away. So it tells you, okay, what happened here. When this closed, this is happened. Natrium channels open, natrium, okay, begins to enter the cell. Okay, and then two, calcium channels open also. Then it goes outside. Okay, natrium channels become refractory, no more natrium, okay. No more enter the cells, okay. Then, but kalium still going out. Okay. So this makes the membrane potential to return to the resting level. The kalium channels close, but natrium channels reset again. Okay, reset. Okay, extra kalium oxide diffuse away. So this is how this is do. Okay, thank you very much. 4:35. Okay. So let's see. Okay, in these few days. Okay. Let me stop recording. Okay, let me start recording. Please bear with me for 2 or 3 minutes.